Hi, I am Kavitha, Assistant Professor, Department of Mathematics. Today's topic is diagrammatic representation in Mathematics and Statistical Computation paper. Graphical presentation of frequency distribution. Graphs which consider the frequencies for the presentation of the data are called frequency graphs. These graphs are used to describe the characteristic feature of the frequency data. The methods for the preparation of the frequency table is already discussed in the previous module. The frequency graphs usually depends on the type of data, whether it is discrete or continuous. Discrete data are usually represented in the form of bar diagrams or discontinuous curves, while the continuous data are represented by means of curves. While constructing the frequency graphs, usually the value of the variables are taken on the x-axis and the corresponding frequencies are represented on y-axis. The graphs that are used for the purpose are histogram, frequency polygon, ogive. Histogram, it is among the most commonly used method for the diagrammatic representation of a grouped frequency distribution. Diagrammatic representation of data. Suppose you are interested to compare the marks of your mates in a test. How can you make the comparison interesting? It can be done by the diagrammatic representation of data. You can use a bar diagram, histograms, pie charts, etc. for this. You will be able to answer questions like, how will you find out the number of students in the various categories of marks in a certain test? What can you say about the marks obtained by the maximum students? Also, how can you compare the marks of your classmates in fire the test? Is it possible for you to remember the marks of each and every student in all subjects? No. Also, you don't have the time to compare the marks of every student. Merely nothing down the marks and doing comparison is not interesting at all. Graphical representation is a way of analyzing numerical data. It exhibits the relation between the data, ideas, information, and concepts in a diagram. It is easy to understand and it is one of the most important learning strategies. It is always depends on the type of information in a particular domain. There are different types of graphical representation. Some of them are as follows. Line graph. Line graph or a linear graph is used to display the continuous data and it is useful for predicting future events over time. Bar graphs. Bar graphs is used to display the category of data and it compares the data using solid bars to represent the quantities. Histogram. The graph that uses bars to represent the frequency of a numerical data that are organized into intervals. Since all the intervals are equal and continuous, all the bars have the same width. Line plot. It shows the frequency of data on a given number line. X is placed above a number line each time when the data occurs again. Frequency table. The table shows the number of pieces of data that falls within the given trial. Circle graph, also known as the pie chart, that shows the relationship of the parts of the whole. The circle is considered with 100% and the categories occupied is represented with the specific percentage like 50%, 56%, etc. What is bar graph? The pictorial representation of grouped data in the form of vertical or horizontal rectangular bars where the lengths of the bars are equivalent to the measure of data are known as the bar graphs or bar charts. The bars drawn are of uniform width and the variable quantity is represented on one of the axes. Also, the measure of the variable is depicted on the other axis. The heights or the length of the bars denoted the value of the variable, and these graphs are also used to compare certain quantities. The frequency distribution tables can be easily represented using bar charts, which simplify the calculation and understanding data. The three major attributes of the bar graphs are: the bar graph helps to compare the different sets of data among different groups easily. It shows the relationship between two axes in which the categories are on one axis and the discrete values are on the other axis. The graph shows the major changes in data over time. This is the example for bar diagram. In a firm of 400 employees, the percentage of monthly salary saved by each employee is given by the following table. Represent it through the bar graph. Savings in percentages 20, 30, 40, 50. A number of employees frequencies 105, 199, 29, 73. The total is 400. This is a solution. The given data can be represented. Here we take x-axis is the savings in percentage, y-axis is number of employees. This is the bar diagram. This is another example for bar diagram. A cosmetic company manufactures 4 different shades of lipstick. The sale for 6 months is shown in the table. Represent it using bar charts. This is the last example is simple bar diagram. Here they give shade 1, shade 2, shade 3, shade 4. Therefore we use the multiple bar diagram. Months are given and the shades are given. Therefore the solution is like this. Months are January, February are denoted in x-axis. The shades are sales or in units are denoted in y-axis. The color shades are differently denoted here, the bars. What is a pie chart? The pie chart is also known as a circle chart, dividing the circular statistical graphic into sectors or sections to illustrate the numerical problems. Each sector denotes a proportionate part of the whole. To find out the composition of something, pie chart works the best at the time. In most cases, pie charts replace other graphs like the bar graph, line plots, histograms, etc. Pie chart formula is given as given data divided by total value of data into 300. Here is the example how to create a pie chart. Imagine a teacher surveys her class on the basis of the favorite sports of the students. Here the data are given here. Football 10 students, hockey 5 students, cricket 5 students, basketball 10 students and badminton 10 students. The data above can be represented by a pie chart as following and by using the circle graph formula. The pie chart formula given below. It makes the size of portion easy to understand. First, enter the data into the table. Add all the values in the table to get the total. Total students are 40. In this case, we convert the data into percentage. Football 10% are therefore 10 by 40 into 100, 25%. Like this we get all the games in percentage. Next, to know how many degrees for each pie sector we will take a full circle of 360 degree and follow the calculations below. We convert into 360 degree percentage. Now we get a football as 90 degree, hockey is 45 degree, cricket is 45 degree, basketball 90 and badminton 90 degree. Now you can draw a pie chart. This is the pie chart. Blue is a football and pink is a basketball and badminton, hockey, cricket. Next, what is a histogram? A histogram is a graphical representation of a grouped frequency distribution with continuous classes. It is an area diagram and can be defined as a set of rectangles with bases along the intervals between class boundaries and with the areas proportional to frequencies in the corresponding classes. In such representation, all the rectangles are adjacent since the base covers the intervals between the class boundaries. In other words, a histogram is a diagram involving rectangles whose area is proportional to the frequency of a variable and width is equal to the class interval. Use of histogram. The histogram graph is used under certain conditions. The data should be numerical. A histogram is used to check the shape of the data distribution and used to check whether the process changes from one period to another, used to determine whether the output is different when it involves two or more processes. Difference between bar diagram and histogram. It is histogram is a two-dimensional figure. A bar diagram is a one-dimensional figure. The frequency is shown by the area of each rectangle in histogram. The height shows the frequency and the width has no significance in bar diagram. It shows rectangles touching each other in histogram. In bar graph, it consists of rectangular separated from each other with equal shape spaces. This is the example for histogram. Here, lifetime and number of lamps are given here in class interval. The histogram for the given data is like this. We take lifetime as x-axis and number of lamps in y-axis. Frequency polygon. A frequency polygon is a line graph of class frequency plotted against class midpoint. It is almost identical to a histogram, which is of data or to display a cumulative frequency distribution. It uses a line graph to represent quantitative data. To draw frequency polygons, first we need to draw histogram and then follow the below steps. Choose the class interval and use it to compare. Setted mark the values on the horizontal axis. Mark the mid value of each interval on the horizontal axis. Mark the frequency of class and the vertical axis. Corresponding to the frequency of each class interval, mark a point at the height in the middle of the class interval. Connect these points using the line segment. The obtained representation is a frequency polygon. Here is the example for frequency polygon. First we draw the bar diagram and then we take the middle point and draw the lines for this. Thank you.